Grantek's Smart Bakery Solutions, really reviewing smart manufacturing benefits that kind of just go beyond the food and beverage industry during your Industry 4.0 transformation. Just really want to thank everybody for joining here, whether you're watching live or if you're going to end up watching this recording afterwards. Really, I'm hoping to provide a little bit of insight into smart manufacturing, just kind of give you an idea of what it is, why it's becoming so important, and really what's happening in the industry itself. Just some of those trends as it kind of moves forward. Although it's probably a broad term, I think it's always something, even for myself, was a little bit confused where you hear a lot of different terms kind of thrown around. I am going to go into a little bit of detail around what it means. I also do want to, spend some time during the presentation talking a little bit about just Industry 4.0, another big term that this kind of involves. And so I will be spending a bunch of time kind of just trying to define some of that stuff, so it makes it a little bit easier for us to get into some of the details. So really the goal of this webinar is really for me to explain, again, as I mentioned, what those terms mean and to help define the concepts around smart manufacturing. I will then talk about just the current state of many plants and what it will take for many, of you and your plants to essentially be smarter in the end. And I think really that's kind of the goal is, what can we do as an industry to make things smarter, to kind of move that stuff forward. Then, as I noted, I'm going to walk through some examples, kind of really talk a little bit about, what we've implemented in the real world. And then finally, I'll spend a little bit of time offering just some tips and suggestions of how, you can go back to your plant and start looking at ways to make things smarter, or ways of, again, like, your organization and stuff can look to do some of that stuff. So we've got a lot to cover, but as always, I want to, do start off with just some general tips for webinars, just to make sure you get the most out of today. Hopefully, you have a good chance to kind of focus on, what we're doing here. Please feel free to use the chat if you have any questions. I will spend some time at the end trying to address any questions that come up. There is a quick poll in there. Just give me a chance to have a quick water break as well. And then, if you have any notes or and stuff, please feel free to take those notes and stuff. It always helps to jot some stuff down, and either, there can be follow-ups with any of those types of questions, or, just again, a good way to follow along with what's happening. Just want to really kind of review pretty quickly today's agenda. We kind of have it broken out into 6 sections. First, we're going to do just like an introduction of background, talk a little bit about myself. Then we're going to jump into, again, as I talked about, smart manufacturing, try to give everybody a bit of a definition around what exactly I'm talking about when I say that. Then we'll delve into some of the Industry 4.0 and what that means. Next, we'll also kind of go over some of the building blocks of smart manufacturing and MES and analytics. Again, all this kind of stuff really ties together, and I do think it's important to define a lot of that before we get into it. Showing there's some case studies. So we'll talk about case studies. It does mention bakery. They do apply to a lot of different industries. And then lastly, there's the, aspects of either, how Grantek can help. I also have some notes around, which, you can do as users, even within your own factories or facilities to go back and do stuff. And then as noted, we'll wrap up with a question and answers. So hopefully that sounds good. Let's get into it. So again, I'm just a quick introduction. So my name is, again, Jeremy Simon. For myself, I love being involved in manufacturing. That's why I think it's kind of natural for me to talk a little bit more about some of the case studies and get into a little bit of this. It's really something I've really enjoyed, is just being out there, being on the plant floor and seeing different processes happen. It's just something I've always really enjoyed. Even just being able to be on site and then talk to people and interact with users and operators and other engineers and stuff. It's always a fun thing to do. Within our organization, I'm our director of client solutions or client success. So I handle a lot of East Coast. So a lot of our customers kind of on the East Coast, as well as some of our other larger customers. For myself, I've been in the industry now for over 20 years, doing all kinds of different stuff from PLC programming to project management, and now handling, again, a lot of our customer relationships. I will note, as a side note, I do wish this was in person. It's always interesting here, kind of trying to talk into a computer screen with this virtual stuff. As much as it's been, I guess a good way for us to at least keep in touch with people and be able to do these things. It is always nice to interact with people in person. So hopefully many of you will have an opportunity to connect with in person in the future. So as you noted, the introduction, now let's get into smart manufacturing. So as I mentioned early on, this is a broad category of manufacturing. So really it employs many aspects of Industry 4.0. Again, I will kind of talk a little bit about, analytics and 4.0 and really try to tie together some of these concepts because a lot of it is important. And again, it's just really, integrated in manufacturing is all of these different types of things. So there's, high levels of adaptability for the smart aspect. There's design changes, digital information, more flexible and technical workforce and training. So, all these things kind of start to kind of come together as what we're going to define as the smart manufacturing. Other goals of this concept can include being able to make quick changes for products for better adjustment to demand and optimization. In this concept, the smart factory has interoperable systems, so like dynamic modeling and simulation, intelligent automation, strong cybersecurity, networked equipment and sensors. It may also now mean getting data from the plant floor up to the cloud and quickly being able to process it. So there's a lot of different advancements and stuff that are happening around that. So, a real broad definition of smart manufacturing covers many different technologies. Some of the key concepts there, again, being that industrial connectivity, devices and services, advanced robotics and processing capabilities. So there's, again, a lot of these different things, and I'll try to, again, break some of that stuff down as we kind of move forward. As I, again, touch on this stuff and this idea of smarts or having intelligence behind different things, I do want to talk about just this concept here from what, advanced analytics. So hopefully, I think it's probably still a little confusing around what I've been saying, but again, that's where I'm going to try to kind of walk through some of this stuff. But one of the things I noted for myself personally was as we started to talk about more like Industry 4.0 and this other stuff, I was reading this actually book, and I'll give credit to there's a book out there called Precision that talks about Industry 4.0 and goes about defining it. And honestly, when I went into reading that book, I expected, the sky to open up and, just be kind of filled with all of this sudden new knowledge of what 4.0 is. And it's like, oh, okay, that's perfect. I get it. It didn't actually happen that way. As I kind of got into it, I was kind of a little surprised and maybe even taken aback. And part of that is because apparently I really knew what most of it was already. I'm sure it helps maybe that I'm in the industry and stuff. So I assume the book was out to explain the details to everyone, but it did at least help kind of connect some dots for me. And I think if anything, this diagram here, kind of shows a little bit about, generally speaking, I guess I want to say like how things are kind of the same. So like if you look at like on the far left there, we have the 1980s and, really, I, for myself, kind of started early 2000, but, really working with a lot of this different type of technology and stuff. You had a lot of analog sensors. There was a lot of, operators out there with dials, and they would adjust a dial and you would expect some type of, some type of change, whether it's an analog sensor or something like that. You would see a gauge or you see an adjustment, and you kind of had a lot more of a, user type of people interaction. As I kind of got in here, and as noted in the 2000s, that's when we really kind of started to see a little bit more of, getting into historian Excel. And so if I use the example of when it comes to control stuff, early on, I did a lot of stuff with PID loops, so like basically doing control loops. And with those control loops, it was very much, you had a historian, you had some Excel or something like that, you had some type of data, and you would kind of watch that data over time, and then I would go in and change some parameters and do a lot of that stuff. As we get into this advanced analytics aspect, so now in this, now in current modern day, now we have different things like auto-tune, or there's different types of software packages and stuff in there that can basically process all of this data real time, to the point where you can even make adjustments real time. So either you're making adjustments real time, or at the same time, the computer itself. So now, again, I'll talk a little bit more about that later on, but just there's that idea now of that this software is out there, and this software can do a lot of these adjustments automatically, even in terms of just the actual, not just control, but the aspects of, say, tuning a loop. From the actual, again, kind of, I keep nailing on this idea of, hitting home. There's a bunch of different concepts we want to cover. And so just overall here, as we look at something like digital transformation, the idea of digital transformation, that's the big picture stuff. So it's the roadmap that an organization will kind of lay out from one state to the latest in technology. For example, the technology to transform a business, something like e-commerce, that's the idea of, this whole digital transformation. So then within that, we kind of, we have this idea here, and you can see kind of on the left again, this Industry 4.0. So the Industry 4.0 itself is actually a German-sponsored research program. Feel free to look that up if you're looking for an interesting read or something to help put you to sleep. But the whole idea there was a program to kind of really transform industrial plants, information, resources, organization, company structure, really highly customized products and using new technology and applications. So it's that whole idea of kind of this moving things forward in this digital way was this what they encompassed as Industry 4.0. So then within that, I'm going to call this definition of smart manufacturing, as I've kind of talked a little bit about before, is within that, those are going to be all the applications and technologies specific to, the industry and stuff, and really being able to kind of, get data up to the cloud and do some level of advanced analytics on it. So there's a bunch of different things around that I note in there. Is there's the IoT and MES, artificial intelligence, MLs, machine learning. So there's a little different things in there, and we're going to kind of talk about some of the definitions of some of that stuff, because that's really what this idea of Industry 4.0 is. It's just that idea of, as technology is advanced, we have more stuff, we have more insight to stuff, and it's that evolution of all of that. Just kind of another little bit of a diagram here, and this is kind of, again, a little bit of a summary from the other one there, where it kind of showed the analog sensor. This has it more of just like the whole overall encompassing software aspect of it. So, for example, the Industry 3.0 aspect there, you can see on the left, we just talk about kind of the different levels of control, the different levels within the system, and I will talk a little bit about that and expand on that shortly. But we can see, and again, if I use that simple example on the bottom there, at the level 0, we have these sensors, actuators, and basic process stuff. As we get to this 4.0, we kind of move it forward. Now we have intelligent sensors. So, and it's the same idea kind of all the way up the chart there. So, and we'll kind of, again, talk a little bit about that chart a little bit later on. But that's the idea there. So even as we see with PLCs and HMIs, that was a big thing that was on the plant floor. And again, hopefully most people on this call are familiar with those types of things out there. But now, even as those things become more advanced, now we have more of edge devices and data concentrators. So, that kind of technology itself there is shifting too into more of a digital type thing, and kind of getting everything up to the cloud. And that's where, again, I do want to, I'm speaking a little bit broadly, and again, trying to define some of this stuff, because it will make a little bit more sense as I talk about some of the examples of how these things are actually taking place now. The other thing I do want to, talk a little bit about is, again, there's some words that get thrown around out there. Also, these always tend to confuse me a lot personally. So again, there's all these different terms and acronyms that people are using. So I'm going to try to just clear up a little bit of that confusion here. And we'll talk a little bit about that. But there's there's around the IoT. So, as we kind of note on the left there, there's, it comes from not understanding the status quo of the internet before the Internet of Things. So that was the Internet of People. So before we had, say, Alexa and smartphones, and smart fridges and stuff like that, almost everything on the internet was a person. So if you kind of look back in the internet itself, was anytime, you were chatting, or anytime that you're doing something, generally something was happening in the background, was always you're interacting with people. And so it obviously people interact with, the internet differently than, say, things do. So people connect intermittently, they log on, they log off. They do, both transactional exchanges, like an email, and real-time exchanges, like a video call. And there's a huge variety in what data they exchange. Big brother algorithms aside, when you pick up your phone, it doesn't know if you're going to FaceTime your sister or check the weather tomorrow or even order dinner. Those are all pretty different types of things. When we get to the Internet of Things, now we're describing how devices, so non-humans, like things connect and interact with the internet, they're more likely to be connected to the internet all the time. So they also need to cover transactional and real-time data. So your smart thermostat may pull utility data once a day, but it's constantly monitoring the weather. It's also, taking a look at, just different types of, things that are coming up. And that's why we all have, cool little thermostat devices and stuff now that can adjust our temperature, when, they know we're coming home, or they'll monitor our schedule and, gets a little scary sometimes, but you have that technology now that you can even have your thermostat adjust as you enter a different room. So this is that idea of like the Internet of Things, where now all of a sudden there's a lot more stuff that's kind of constantly happening in the background. We're constantly interacting. You're constantly having access to, unfortunately, too, as well, more computers on the other end. So you have a lot of automatic type of stuff that's kind of generated, which is pushing us more towards like that AI aspect of things, having the artificial intelligence there. Lastly, there's another term there, the IIoT. That's really like the industrial Internet of Things. So that's again, since there's there's things always connected. Now we're more likely to send like historical data. So here are all the torques on a robot motor for the day, and the data is modeled. A robot is always going to kind of send the same data points, but the variability and predictability of that data is a little bit more complex. So that's where we kind of get into the industrial side of things. So just from your simple thermostat trying to do stuff, on the industrial side of things are going to get a lot more complicated. There's a lot more data there. So that's, again, just kind of wanted to give you some definitions and stuff like that, kind of go through that. Now we're going to just talk a little bit about, MES and just kind of its role in being smart, again, before we kind of get into some of the examples and stuff. As I kind of showed on another slide there of just showing between Industry 3.0 to the idea of Industry 4.0, it kind of talked a little bit about the different levels. And you can kind of see, this functional chart here. This comes from the ISA 95 functional hierarchy model. And it's been the standard model for about over 20 years now. And this is, we'll call the most common reference. And this is something, Sam, who's one of our smart manufacturing directors and handles a lot of stuff at Grantek, has always introduced me to, and kind of, always kind of goes back to this. And I think it really does give and show a good example of kind of where things kind of fit into play. And so, as mentioned, you kind of have this level 0 is that transmitters. Level 1, you get into like the PLC field devices. Level 2, you have your SCADA historian. And in level 3, we have our MES system, so our manufacturing execution system. So really it's this, I'm focusing here on a moment because this is where a lot of the software that you're going to kind of implement to make things smarter and start to tie the level 4 all the way down to the level 1 and 2 together. So that's why I'm just going to kind of focus a little bit on that, just to kind of highlight and show how this is that piece that's starting to tie all this stuff together. And again, as this technology is advanced, it's made it easier to be able to implement and put a lot of these types of systems in place, which again gets you to this idea of being able to make your factory smarter. So just we're going to talk about some of the benefits here. You like a factory can expect if you're to go and implement some of these types of functions. Really, it's that idea of now, leveraging Mesa. I mean, this is a Mesa example here. You kind of see in the bottom left-hand corner. You can go to mesa.org to get this information. It's all up there. But this is something, it's been kind of defined by, Mesa International and Gartner, just around kind of the benefits that companies are actually reporting from their MES installations. So your MES system, can be a great way to get a paper or manual operations, off the plant floor. There's a variety of MES systems, that we can support. Just, as an example, I'm just going to know like one of them, is Ignition and the Cepasoft, and they work well in this case because it allows us to, again, be able to bridge the different layers and stuff together. There's a lot of like custom type code and stuff that has to happen. And being an open source really allows us to kind of go in there and be able to take a lot of this data and move it back and forth. And that's where we can see like the second one over there, there's, the electronic enforcement of processes. So now we can take data that's up in SAP and be able to move data down to the plant floor. MES is also a great tool for managing your operational processes, guiding operators through, what's expected of them and confirming that their tasks were completed successfully. For factories, that don't have like a mature MES, usually you'll end up kind of finding like Microsoft Excel filling in a lot of the gaps. So if you still have a lot of people that are still using Excel to do, data collection, quality control, or, such things as like scheduling production runs, or, basically like moving order data or run reports, then in that case, like there's really, a good opportunity for you to automate those processes. So at this point, all of that stuff can now really be automated. So it's something that would generally save a lot of time. And as you automate these tasks, you're also freeing up, the human resources to do more value add work. So transcribing paper quality, records to an Excel workbook, then copying that information into SAP is not really a value add task for your operators. A few more quick ones, just kind of along here, is there's lot tracing and genealogy can be critical for material management and recall situations. I mentioned on the last slide that MES can not only help manage multiple processes at a site, but it can also streamline the management of multiple plants for your global headquarters. So there's just, again, just this idea of to kind of cover, there's a lot of different value add to that stuff there. Again, I'm getting a little bit, definitely, kind of reviewing a lot of different things here. I'm almost kind of wrapped up with some of this stuff, but again, just wanted to touch a little bit more on some of these additional concepts. And that's, I mentioned the advanced analytics aspect. So I hope everybody's still kind of following, but I just wanted to, again, really try to run through this, real quick. When we talk about analytics, there are 4 different types of analytics that we're looking at here in this chart. Kind of helps to define some of that stuff. So as we look at descriptive analytics, which are the most accessible, they describe what's happening now. These aren't very complex and are valuable, but this is kind of like, well, it's old news, but most manufacturers have the tools they need to understand the current state of affairs. So again, as we look at advancing into analytics and smart manufacturing, the descriptive type stuff of what's happening and why it's happening, we already start to have a lot of this stuff. So at the diagnostic layer, which is a layer just above, we start to get into some more of the recent analytic trends in predictive. So we kind of have the diagnostic, we start to see what's happening there. And instead we get into this predictive. So now we're using data from the past and present to predict the future. This is a really hot topic right now in 4.0. And again, we're going to talk a little bit more about that in some case studies and example. But predictive maintenance is a good example of that, to reduce unplanned downtime or predicting production results to help with supply chain flow or the ability to promise deliverables. And then finally, just real quick, there's the top of the pyramid, you have prescriptive analytics. They not only tell you what could happen next, but what actions to take and what to do in response to an insight. This is the most complex type of analytics, but again, can change your entire business operations if you do it right and can commit to it. So again, as we get into advanced analytics, it really provides a lot of, a lot of opportunity and flexibility as you kind of climb up that the pyramid. Again, just that one little, advancement of that analytics. What does that mean? So again, just where, this chart kind of describes the stuff. And as noted from the other one there, you can kind of see, I had talked a little bit about the analytics, and we went from, the 1980s to 2000s to the 20s. This just expands a little bit more on it. Again, I'm not going to talk about this too much, but it's just that smart sensors, we have an exponential increase in data. We now have connectivity from the plant floor to our ERP systems, all of our scheduling systems. You have access to all of that now. You've also got the big migration from, data on the plant floor up to, really getting up into the cloud itself. You also then have, new types of communication protocols and stuff. So, we have, two new big protocols and stuff that are, handling efficient ways of data transfer from PLCs, again, up to, your MES system. You get OPC UA and MQTT. So these are types of things that are helping to simplify that. And then as noted, lastly, there's artificial and machine learning. I will talk about those a little bit. And actually my next slide is going to kind of touch on that a little bit, but those are, I would say, kind of on the cusp of the next stages of all of this evolution of smart manufacturing. And so as noted, as we start to get into advanced analytics, I do want to mention this whole idea of the digital twin. I've heard this term a lot. Many of you probably have too. Really, the goal being here is to replicate a line to do various simulations and other things. The key here, as the diagram shows, is the digital twin is heavily reliant on your physical process and the ability to gather as much data as possible. That can be a challenge, and that's where it really does take your floor being at a good spot to be able to have that data you need to be able to do some of the stuff. So it's the data and the interpretation now of this line or this machine or something that you're trying to simulate that really allows you to kind of set parameters and model, what that line's doing. That's that idea of the digital twin. So it really is like a close approximation of what you have in place. So, to try to think of like a good simple example here, if you were to try to model it, would be if you were to take something like a pump. So this one kind of shows a pump, and that's kind of why I like this one. But if you take a pump, and we wanted to be able to do some simulation on that pump. We really need to have all of the model information for that pump. So we need to, be able to measure, the flow and pressures and temperatures and, I'm trying to think like other types of things like vibration. These are all types of things you would want to measure on a motor. And now that you have that information, you can start to trend that information, record it over time. Then what we could do is say, like as an example would be, let's say I want to run that pump at 50 gallons per minute. I can record that data and have that data at 50 gallons per minute. I can then say run it at 100 gallons per minute, have that same type of data and be able to kind of see what's going on with that type of data. And then that allows me now to simulate other things. So let's say I want to see, what happens at 125 gallons per minute. So then without actually having to go out to the pump, I might not actually want to run it at 125, but I want to see if I can simulate what would happen at 125. And it allows us to be able to look at other types of things related to that. So maybe we come to find out that with the increased temperature and the other cooling and other stuff that's required, it consumes a lot more energy running at 125 than if we were to just stay at 100. So maybe there is no real cost savings or value of us running that pump at a higher speed. So that's the concept really, again, there of that this idea of the digital twin and getting into, almost some of that artificial intelligence. Just a real quick, as I've kind of gone through all these different concepts, I'll just note that, as we've implemented a lot of this different stuff, we are seeing a lot of different savings. Just being able to implement, MES systems and OEE, you can see, a large improvement in terms of your overall optimization of the plant and performance. Also, just a general plant and maintenance operations, you're seeing a lot less waste, reduced material scraps, and you're having higher yields. Also maintenance savings, just reducing downtime. If you're monitoring a pump, which again, we'll kind of talk a little bit about this, if you're monitoring a pump and you can predict or have an idea if that pump's going to fail soon, it can save you a lot of downtime, to make sure you have a pump in stock to replace it. Lastly, just real important to touch on because it's becoming a very huge topic and stuff today, and I mentioned this a little bit early on, but the whole idea of IT and cybersecurity. The real thing to note here is, again, as plants have gotten smarter, we see that originally the whole idea of automation, or we call it around IT, around your networks and stuff, was these idea of independent islands. So everything in itself was kind of like an island. So you had your manufacturing was its own little entity. Your warehouse or packaging would be another one. Your building system. All of these were different, like individual islands. As we can see now, and you'll probably hear these terms a lot. Now, as we kind of move forward, now all of a sudden, all these networks, they're all tied together now. So now we're finding out that everything is going to be tied together. They're all going to come into the common different switches, these core switches. And then from there, they're either being VLAN, or you've got firewalls, or you have all these different types of things out there. It's not my goal to actually really get into any of that, but I just want to make sure that I discuss it because it is becoming a very big thing, is this whole idea of networks becoming smarter and how they're set up and how they're configured. There's a lot of value, and we're starting to see a lot of issues with, if your network's not set up properly, you can either run into issues with potential cybersecurity attacks, or even just like things along the lines of like performance. You might see, different types of performance issues on your plant floor. So again, that's that idea here. We've gone from this islands concept, into, more of this transformation now of your networks kind of really being this whole one complete concept. All right, so that kind of covers the background. I don't know if any of that made sense. So I've actually just got a quick poll question here. This is actually going to give me a chance to have a quick drink of water here. But, if people don't mind just taking a moment, there should be a poll, I think, that's going to pop up in the comments or something that, just kind of, I am curious to see, just for people attending this, of where you're kind of at within this whole, industry transformation of things. Oh, thank you. Getting thirsty here. All right, so let me move on now from the poll. So now we're actually going to get into some case studies. So let's start talking a little bit about just, again, hopefully I've done at least a decent concept introducing this idea of 4.0 and how we're taking this technology and it's kind of moving forward. And then now what I want to be able to do is I kind of want to get into this idea of talking about how we've implemented some of this stuff. So for this first, we'll call this first case study in the situation here. What we've got like batches and product quality. So again, this does tie a little bit more to the baking side of things, but it also easily relates and translates to whether you're making crackers, cookies, bread, juice, beer, all these different types of industries where you're having to do some type of batching process. That's where it really becomes important for you to measure your standards and consistency, just to really have that process down. Now, this is where if you have R&D groups, or you really do have to really understand your consistent, what you're looking to measure from batch to batch. But what we can see here in this particular chart is if you can measure something like, and this one just kind of shows dough. If you're measuring your dough during your process, you start to understand and see what your process is doing. And so in this particular case, you're looking at essentially the resistivity, of your batch. And as you measure that, you can see on the bottom there of the chart on the right-hand side, you can see it kind of generates a curve. And so when you make one batch of a product, you would expect there to be different types of parameters and stuff that you're measuring as part of that. And this is probably nothing new if you have Historian or something like that, where you start to collect and see some of this data. Where it comes into play now, and where the smart aspect has come in, is we have the ability to measure these types of things, really well now. And it used to be a lot more difficult to be able to do some of that stuff. Some of the stuff used to require supercomputers or things like MATLAB or stuff like that to really be able to process this data at a high enough speed and be able to kind of generate a lot of that type of, the type of charts or the type of stuff to be able to do some of this stuff. As technology has advanced now, we are at the point, and we've been able to implement these types of things where you can take a chart like this and you can start to measure, and now we can start to see, well, the actual batch is being mixed. Let's say, you've got, looking at something like a cookies or other stuff, if you have water and flour, then you start to measure how much water and flour is, being added. If you start to find out that something's deviating, we can now look back, and we have historical data, almost that artificial intelligence aspect, to be able to say, oh, wait a sec, we need to add a little bit more flour. If we add a little bit more flour, we can save this process or save this particular batch. So that's really kind of being able to do that has allowed us to go in and implement this idea of smart mixing for our customers, where we can now go in and through the PLC or other type of application, you can actually go in, pause a batch, and allow your system to be able to adjust. The savings there is you're saving a lot of money in materials. You're saving a lot of, just kind of getting the raw material aspect you're saving, or you're even saving stuff down the line. If you go to find out that, you make a batch, and if you're not doing your quality checks and stuff till much later in the process, you may have already made that batch, you may have packaged it, palletized it, and then all of a sudden find out later it doesn't meet your quality standards. Now all of a sudden you have to go back and figure out, where's all this product and how can I, recover and dispose of it? So now all of a sudden you have this extra wasted product. So being able to make these decisions and do this stuff almost real time can save you a lot of money. So that's really, again, this example here is right, from the early stages of mixing, we can start to analyze that data and be able to do stuff. In addition to that, and I'm going to just talk a little bit about here is, the idea again of batch quality. The other one being the idea of baking or mixing. This one kind of relates to two different things. We've got chocolate. I kind of show chocolate there. And then I also show there's the chart with respect to beer and specific gravity. But if we take a look at these, in this case, it focuses a little more like, again, the liquid side of things. And so again, there are other parameters and other ingredient concentrations and stuff that we can measure, as part of that process on the beverage or liquid side of things. So again, this is something too where, really it might take you working with your R&D department, or again, really understanding what becomes that key component, as part of that process. Again, as this particular examples are showing here, if you're adding liquid or solids into the batch, the concentration becomes key. So now you have instrumentation that can measure concentration. And again, we can actually, monitor that closely for the ingredients going in, and then be able to determine if we need to change something. So that way you're kind of, again, doing that batch quality check right during the actual process of mixing it. So almost even an older term that you would come up a lot as an idea of the golden batch. So now we have the technology to be able to kind of implement the golden batch on the fly. This, again, just that saves a lot of money and effort downstream, a lot less waste. You can check, again, a variety of different things. If you're measuring beer, you can check specific gravity, so you can see and make sure you're exactly where you're supposed to be for that particular beer before you bottle it. Again, saving those materials down the line. Another example is, as I mentioned, chocolate. You can measure the viscosity now of the chocolate. So like these are different types of things you can measure, and based on those measurements and stuff, again, be able to have enough historical data and have the ability for your system to measure that to determine what types of ingredients or other stuff you might be able to add to save that batch. And so that's really the kind of the goal here, is us being able to do a lot of these checks much sooner in the process saves a lot of time down the road. And again, that's where a lot of these systems too, as they tie together or they interact with each other, it really becomes key for them being able to kind of, be able to respond better, or like be able to communicate with each other. So, and again, I'll talk a little bit more about that as I get into some other examples, but you're now able to take a lot of this data from the plant floor, right from your batch and mixing, and all the way up to, your MES level system, which, it's, let's say, corporate. So, again, corporate can even be monitoring this stuff, as it's happening. We have also seen it as an example when it comes to mixing or other stuff, is just even being able to measure, say, the humidity in the room, so you can measure the humidity in the room to see how it affects your batches. And again, now you have that ability to go back as part of that whole analytics aspect and see exactly how the humidity in the room affects your batch quality as well. So again, it's having a lot more information, and now we have the systems and stuff in place to actually be able to measure a lot of that stuff and determine what's happening. And that's really kind of where this stuff kind of comes into play. So hopefully, as I've kind of gone through that idea of smart manufacturing and transmitters and how they're smarter now, to the software and stuff behind it, to be able to show how now you're able to take a lot of this stuff and we can actually translate it into being able to do more intelligent things on the plant floor. In this particular example, I'm just looking at the baking process. So, again, another process where we can take certain things. So like if, you're looking at your baking itself, stuff that becomes important as part of that process would be your temperature, your flow in the ovens. And then there's also instrumentation stuff that we've used now that are actually able to measure like the degree of cook. So, say the color of the product, if you can tell if your product comes out and kind of like your toaster, is it too dark? Does it meet your quality control standards? Do you need to either reduce the temperature or, potentially speed up the conveyor through the oven? So these are types of things now where you can measure some of that. You also have device and instrumentation to measure moisture content. So now once you start to take all of that information, now we have the ability to take that, and now we can go in and now we can improve our processes of our ovens. So now we can go back again, take that as we're seeing it come out, and instead of having to potentially dump a lot of product, you can actually adjust pretty quickly. So that then again, as we adjust, now we can save that product down the line. Excuse me. So again, if I was to take something like the degree of cook, of how well something is cooked and if it meets our quality standards, me having a vision system or having a sensor or something that detects that, I can adjust that oven much quicker than being dependent on an operator on the line, taking samples off the line, having to go back to the quality lab to figure out if there's a problem, and then, radio ahead for whoever to be able to make whatever adjustments. These are the types of things you can adjust much quicker. And again, the idea here is save money and a lot less wasted product. When it comes to bakeries and stuff, like product waste is one of the biggest, cost factors there. Recipe management, again, another area like this probably isn't something that's totally new. I think the big thing here around recipe management that I wanted to mention was the idea of consolidation. So, again, you would have, if you had a PLC and an HMI, generally speaking, that recipe resides on that particular system, or it might, sit on your SCADA system. The thing is, at some point, that data, where it comes to in your SCADA system, probably came from some other type of system, say something like, SAP. And so the goal here is right now is just as you have these different platforms or methodologies, the goal here is it's become crucial for customers to be able to consolidate all of that. So you really want to be able to tie it all together. There's effort, saved just in that idea of centrally managing and monitoring those details. And again, it's, I mentioned the recipe management system, but there's other parameters and stuff that could also be key. And really having that data centrally managed or having those systems tied together, again, can be crucial. Again, the idea is, we mentioned the idea of value earlier, the idea of the value savings for operators. And part of that is, even this idea of going away from paperless, it's also, from recipe management or these other types of things where you're dependent on somebody to verify parameters or enter stuff incorrectly. If you have these systems set up in place to be able to do that automatically, it becomes key. So as you have information that might change on, the SAP side of things, that information then can actually be sent down to the plant floor and kind of, automatically adjust accordingly on the plant floor or even be displayed on the plant floor. This mentions recipe management. A similar concept would apply to something like scheduling. So we have done things with scheduling where same thing. If your schedules are and your production runs all reside in SAP, being able to have that data displayed on the plant floor is much easier than having somebody go in, get the data of SAP, put it into Excel or something like that, have to go out and print out some schedules and update some stuff on the plant floor. You can just have a monitor on the plant floor that updates automatically. And so really, again, that idea there is that technology is there. And so now we've been able to implement these types of things where, you can really kind of tie this idea of having these consolidated systems together. I'm going to talk a little bit about this one in more detail. There's a lot of stuff I kind of have covered in one slide here. I probably could have made this about 3 or 4 slides. But as I was going through, I found that if I end up having 3 or 4 or 5, 6 slides, I end up talking too much, which you can probably see I like to talk. And so what'll happen is as I'm trying to go through that, there's a lot of different things, and then I just end up talking too long. So I tried to consolidate it, but if I take a look at smart packaging, it's the whole concept here again is just a couple of different things around checkways, in visual inspections and label verification. There are other things, we're doing kind of that packaging, but these really highlight some big things that, are kind of happening in the industry. So, and really the situation as described in this particular case study is, we've seen a lot of product recalls. These generally tend to be for mislabeling type things, and it's become a big problem in the industry. It's also something even in terms of pharmaceutical companies do a lot of this. So it kind of originated with the idea of pharmas following the track and trace standard. So, as much as that's great and it would be neat to do, it's definitely a lot more intensive than it's required kind of in the food and beverage industries. But the concepts for us to be able to implement large parts of that is there. So again, as we're kind of seeing in this case on the right-hand side, you see this label verification. This allows for us to scan the barcode. So if there's a barcode or a 2D barcode on there, this allows us to ensure that it's the correct product and basically it's in the appropriate box. So if you have a box, we can make sure that you're putting that appropriate thing of what's supposed to be in that box in that correct box. And to do that, we can verify based on the line. Again, we can go back to SAP, see what order information is there and see what should be running on that line and make sure that that matches up with that barcode that we're now reading on that box. Similarly, it's also in case of, let's say you have an operator is going to, accidentally load the wrong boxes or something like that, or the wrong label, onto a machine. This is going to help you verify that it is actually the correct thing. And again, this is something where, we have seen with our customers, it's kind of come up a lot where we've helped them save lots and lots of money, time, and effort, especially when it comes to types of things of recalls. You are also capturing a lot of this information. So even if you do see a situation come up where there is an issue and you do have a wrong label and your system will record that, and then you can have that information available to say, oh, you know what, this happened at this particular time. And then now we have traceability built in the system to say, oh, you know what, it happened during this time. That correlates to these 4 pallets. We better go pull these 4 pallets and take a look and see, kind of where that happened and what happened there. And, we can do some root cause analysis. The other thing here is, as technology has advanced, it has become a lot more cost effective to do this type of thing, as well as just the speeds. So speeds is another big thing for cameras and processing. The speeds are there to be able to do a lot of high speed items on this type of stuff now. So label verification is a big thing. Again, as I mentioned, I could probably talk about this for hours. We do have some information on the Grantek site if you are more interested in that. I think we might even have some webinars on it, but there is a lot more information out there on it. But again, just that idea of that intelligence that's behind there now for us to be able to follow product along through the entire process. So we can really track it. Checkways, touch on that one. Again, the idea there is as you have different machines and different lines and different spurs of lines making different products, the goal with checkways is we now again have that ability to have a lot of information collected at a single point in time. So now we can capture individual weights for products, and we can determine if they meet the requirements. So in terms of an FDA requirement, making sure that you're putting as much product in the box as you say you are. A lot of times, what happens is people put too much product in the box, so your box ends up weighing more than you need to, and at that point, you're actually just giving away money. So a lot of people have found a benefit now for us to be able to check that, so we can actually connect up to the checkways, really be able to collect all of that data, compare it to what it's supposed to be, and then potentially highlight or note issues, say maybe it's a particular spur or a particular machine needs to be adjusted. So we can actually go and adjust that machine accordingly, which again is saving you a lot of more money down the line. And then I did note just a little on the bottom left there's the inspection systems. Again, inspection systems have been around for a while. Again, the idea is the technology keeps getting better, and unfortunately, in the case of cameras, also getting cheaper. So it becomes much cheaper for us to do, your type of inspections to make sure that your cookies are coming out properly, your packages are intact, to see if there's issues with packaging or broken crackers or, broken cookies, or like we see a lot with bottle inspections to make sure the fill levels are correct. So these are all types of things that can happen at a high speed now, which again save you a lot of potential quality issues down the road. I do want to touch here a little bit on logistics. Again, just a real simple thing with the logistics here. The idea that we've seen is a lot of our customers have kind of come to us with the challenge of, I need to be able to take more data, really be able to kind of take it up from the cloud and get it down to the plant floor and vice versa. So here is just an example of, our ability now to be able to take data from the plant floor, so we can take all of the pallet information, shift, production, and all that information, and we can basically sum it up to SAP. Similarly, we can collect the information from SAP, such as order information as to which pallets to pull or other stuff, and bring that data down to the plant floor, communicate with those systems, and be able to kind of have those systems communicate together. So really, again, just the idea here is, it's much easier now to be able to do that, to get that information up to SAP and down from SAP. So, as technology is advanced, it's becoming a lot easier to do that. I mentioned IT and cybersecurity. Again, this is just more of like that note in here, just for me to highlight the fact of, you have all of these different types of networks that were all islands. Now they're all kind of coming together. You can see now there's a lot of different software out there to be able to start to automate that and be able to manage those networks. So again, we can generate reports or different types of things about what's happening with those networks. So again, it's something that's out there. We do have a group, and I know, again, we've got some material up there that relates more to that side of things. And not being an expert and all that stuff, I want to make sure I'm doing it justice. We've got MES, and again, I really talked about MES earlier, and most people are probably already familiar with that. But again, I did want to just kind of note that idea here of, having those MES systems out there and really having a lot of that technology and stuff to be able to kind of monitor your downtime, really be able to do, optimization, check for bottlenecks, quality, that information's there and available. And again, now that next step is not only can we display it now, we can have a lot of our systems really be able to kind of go back and start to do things automatically or be able to flag types of things. So it used to be, again, this would be, something that shows up on the plant floor as a dashboard. The goal here, as we're moving forward into the smart aspect, is it's not just a dashboard. That system is going to start doing stuff now. So now that system is going to start to interact with equipment on the plant floor, or it's going to be able to be easier for this information to get up to, we'll say, like the corporate level, to be able to have corporate decisions made on that. And then just a last thing, I don't really have too much to kind of show on these two particular items. Main reason is these are kind of the newer, I'll call it the newer things that are happening right now. We have seen some stuff with digital twin, and we've kind of helped a little bit. Again, that's more of something where we would rely on our different software vendors who really focus on this stuff and have developed a lot of that technology. So it's really more of a third party thing that we've kind of helped. But excuse me, but it's just important to note here, though, that this does exist, that there is the digital twin stuff out there. Again, it is something that is happening, and there is a lot of value to it. It's a little bit more difficult, as I noted, as I talked about there, because you really do have to make sure you have the appropriate information to really implement that. But if you've got that information, it's definitely a good option. Another item, too, is artificial intelligence. Again, another big thing we're getting a lot of requests in for that is, as we have all this data, what types of software, what types of applications or configurations or types of things or modules do we already have set up that you can utilize that utilize a lot of this AI? And so as you can see, we kind of have a lot of different modules built that we've kind of been helping to do some of these types of, we'll call it artificial intelligence. So again, making things smarter. But then as noted, I mean, this is something that's always kind of continually growing. Others, I mean, there's other ways companies are innovating, and I'm sure there'll be another big jump to something around the corner as well. So it's something I probably haven't seen yet. Just again, as we kind of get to the agenda here, I want to make sure I save a little bit of time to get into any questions and stuff that may have come in. Just going to talk a little bit about how Grantek can help. So I mean, obviously, as Grantek, I mean, we could definitely help you. My biggest recommendation is, for all the individuals on this call is, the biggest thing you can do is probably kind of go back to make sure, you check like these three different things. So as I note here, really for a successful smart manufacturing program, you want to check data availability. I mean, that's a big thing. Make sure you've got that data. Next becomes all the kind of analysis tools and other stuff that are in place. And then really it's also enacting change. I mean, we've all seen this before. You really need that kind of the plant itself to get behind this change and support it. So that just as we kind of touch on it, data availability, really it's that, making sure you've got a lot of these different types of systems in place to have that communication from the plant floor up to your business systems. And then there's just some notes here, like you can also consider, as we advance now, the next steps being is, moving this data up to, your IoT, your data lakes, or, we talk about, with OPC servers and stuff and being able to have data concentrators. So these are kind of some of those next steps as well in terms of getting that data. In terms of tools, again, that's the next big thing is what kind of tools do you have available? You may have a lot of the stuff available already. That's where it might be worth talking to, some of your plant manager, engineering staff and stuff to see what types of tools you may already have, or look into what types of tools and stuff that may be helpful, again, depending on what you want to do. As I noted as well, it's just kind of like that enabling change. Really, takes a big thing. You want to be able to have these types of alerts or interventions to be able to go back and make these changes and improve quality and do that stuff. Live feedback's always good, as well as just like, projects. There's a lot of projects happening out there, and I would imagine a lot of companies are already kind of moving in this direction. Just some other notes and stuff here. Again, I know I've kind of gone over a lot of things. Again, if there's, different ways and stuff we can help. But one of the big things to hear is the note is use your intuition. Don't discount your own intuition and experience. You've probably got a good idea of your current data, what kind of, what's out there and analysis of it and your capabilities. Trust your gut. Could be that easy. Just a great starting point is to go out there and trust your gut and, see what kind of changes you can implement. There's a lot of tools out there. I've mentioned Mesa. Mesa's got some great stuff out there as well, if you're interested in some of the details around it. So there's some different cool tools and good ways to go out there and be able to kind of do some of that stuff. I also just some partner stuff, and I just kind of put this on here just to mention, like, again, as an integrator for us, we generally use a lot of different companies. And so we're using a lot of these different, softwares from our different partners and stuff to implement a lot of this. Also noting, again, we have a lot of stuff we're doing with the cybersecurity. Again, we sit on a lot of different industry boards. and then have some different certifications and stuff that, allows us to really work in a lot of these different spaces. And then just the one other thing is, and I'm kind of mentioning this, is Grantek for MES has really taken on this agile approach. And I'm kind of mentioning this mostly because I think it's a benefit to you as the customer, is even to consider, this type of approach just to, looking at your system. So, the MES solutions now at this point have actually been around for almost 20 years. But where we've seen more successes and more of an agile approach, and it's rather than just kind of go and just dump a whole system out there. The idea here is, and again, I'm not going to spend too much time because we do have a lot of this information out there in other places, but the idea there is to really kind of just go out and be able to do a proof of concept, check it, make sure it's kind of working, and then evaluate it. So it's almost like starting smaller, doing something, evaluate it, making sure it's working, like a prototype or something, and then kind of going back and evaluating that overall. So again, I don't want to cover too much on here. I know I'm running a little bit short on time here, but the idea would be to kind of come in first, understand the process. So just understanding where you're at, where you want to go, and helping to kind of figure that out, to figure out what's involved and what your digital transformation looks like. Do that kind of, proof of concept. As I mentioned, this idea of the agile development, at that point, then you're going to develop and then check for success. So that really kind of covers, the main thing there. Now I'm going to get into just some kind of questions and answers. I did kind of want to touch base on that. I want to see, I have to check the poll results there. For everybody in the poll results, let's see, we got here. It looks like 45% of you are at the moving along point. We've got about 15% of making great progress, another 30% early progress, and another 10% of the what is 4.0. I threw that in there as a bit of a joke, but I think one of the key things there is just, again, is there is a lot of information, a lot of stuff that's kind of happening, and if anything, I do hope this kind of presentation is to help to cover at least some of that stuff. Again, I do actually, it looks like I got 2 questions that have come in here. I guess the first question is, let me touch on this. I'm getting a little bit short on time. Somebody had mentioned what are the disruptive trends that I see in the industry? Disruptive trends in the industry. That's a good question. I would probably say Sam, who's our main smart manufacturing person, might be the better person to discuss that. But I would say, I guess if I had to say from my experience on the plant floor, I'd say it's probably the speed at which we're getting data now. I think to me that's really changing things and how fast things are going. It's really forced us to try to make really big network improvements. So we're kind of seeing just how all of that flow of data works. I was talking to somebody the other day about this, and I was just saying, like, 10 years ago, you used to go to your, maybe longer, go to Blockbuster and, rent a video, and you go home and watch your video. These days, you can pretty much just go on your television and within seconds almost download a new movie to watch. Like, that's how fast we've advanced in terms of moving of data. And so I think that's becoming one of those big trends right now, is how fast data is moving, and really being able to, move things forward and really kind of move that data up to, the IoT. So moving it up to data lakes, or again, another concept I never really touched on as much, but it's really being able to kind of do that type of stuff. And I think the other thing, actually, now I'm thinking about it, to note on there would be, the idea of having data accessible. So, again, you have a lot of smaller companies that can be more agile and do stuff. For larger companies now, as you have access to that data, it becomes easier to be able to do stuff quicker. So you almost have like a production on demand type of thing now. So you kind of have access to that system. Corporate could quickly change, maybe say order information and adjust to a new product or something like that. And then now you have the ability in the production line to be able to switch that pretty quickly. So whereas something like that might take months, or by the time that order information comes in, it could be months, weeks, something like that, to be able to switch equipment over. You can pretty much do that on demand. Another example, actually, I'm thinking about is we've seen a lot of stuff around like beer and seltzer, and I don't know for anybody who's familiar with that, in those types of industries and stuff now, those types of things are, flavors on demand become a big thing, where it's like you see, people want these new flavors, and it becomes very easy to quickly adjust to that. Anyways, just want to, I guess I've got to, I've got to close this thing out here. We are at time. I think I have one more question, and I'll try to kind of cover that as I close this out. But if you do have any information, please feel free to email Grantek. Check out our website. As noted, this webinar will also be available up on. We'll put it up on the website and give everybody access to it. If there's anything you wanted to go back and review, or if you do have any questions and stuff, please, as noted, please feel free to reach out. I'd be more than happy to talk to you. I mean, we have other people on our team as well that would be more than happy to talk to as well. So on that note, again, I do thank you all for attending. There is the one other question, and again, I kind of go into overtime here on this one, but I did want to kind of cover it. Is somebody had asked why invest in this smart technology and why now? And I think the big thing is one of the main reasons for this is that technology is improving, cost is decreasing for this technology, and again, I'm seeing a lot of, like in our case, a lot of our customers doing it, and so I do think there is a really big push and a really big need for a lot of companies to really start evaluating this and trying to push themselves forward to be these advanced manufacturers and stuff like that to kind of compete with the global world. So definitely something I think is very important. So if there's any way we can help you with that or anything we can do, again, please feel free to reach out. I'd be more than happy to answer any additional questions or even provide additional information around any of the things we've discussed. So thank you very much for your time, and enjoy the rest of your day. Thank you.